Hi everyone, I hope you're going well. Today, we'll introduce the second part of Lab 6, the modeling. Firstly, we need to load those packages as we did before. Even though you must be familiar with general utilities, for the rest packages, I'd like to introduce a little detail. By the way, we may not use all the packages imported here, and if you face problems importing Plus and Line, you can move them as I think they may not have influence. These packages were some basic tools for our task. For example, the module named train test split can be used to split the training set and the testing set. And the matrix can help us understand the performance of models well. These are our classifiers. We use different classifiers to deal with the battery classification, whether default or not. The regressors and other tools like a visualization module were here. Finally, we use the packages to avoid warning messages. It's on my own custom. You can choose to delete this line so that the warning message will output normally. We have already explained those two functions in this note. However, additionally, I say that the functions will be used only when you choose to output your result, so most of the time, you may not use them. A random seed is a number used to initialize the pseudo-random number generator. And if you like to output a result, you can define the name of your output file here. And this function is also used to put your result into the file. We have defined the types of columns well in our clean data so that we can load this data and features directly from our cleaned Pico file. In order to simplify the loan status for your prediction, we generated a new column named outcome, which is false if loan status is fully paid. Otherwise, it is true. Next, make a new feature for the length of credit history. Here we random choose our training set and testing set by adding a new column claiming the splitting. Eventually, our data got prepared partly well. Next, we define a function to prepare the data for classification or regression. Each parameter has been explained in details in the notes, so we won't see much about them. You can find the details in these notes here. Okay, so in order to fit model and evaluate it easily, we also define two functions here, one for classification and another one for regression. It just puts the fitting steps and evaluating steps together so that it's not hard to be understood. Actually, our goal is to implement machine learning in investment. So surely we should test some investment strategies. Although we define 5 strategies in the function, only 4 of them were used: random, ranking, regression, and 2 stages. You can find the details about them in these notes. Now, we will start our machine learning attempts. As we know, the lending platform is not assigning the grades and interest rates arbitrarily, and they tend to reflect some critical information about the loans. Thus, if we just use the two features with a simple classifier, logistic regression, what will happen? Actually, as shown in the result, they present a good performance and only on the non-defaulted instances. Next, let's try our own attempts without those features generated by the platform. We use 6 different types of classifier here to predict the default and compare them with each other. Random forest is absolutely the winner. You can find its performance here. You can find that it presents a good performance, particularly on the default instances. And 5 types of regress were used to predict return as well. I think random forest regressor actually is still the best one based on the asked. The learning curve is a good reference for us to understand the models, so we can also take a look at the curve. Here we just take the logistic regression random forest as our examples. Before investment tests, we like to test the time stability. We used the random forest classifier as our base model. We tested the model on 3 different time range, and we can find that it always performs well on the whole time period, tree and test on the first 2 years, tree on the first 2 years and test on the last year. Okay, so finally, we can start our testing for investment strategies. I believe your finance domain knowledge can make you understand the difference between the 4 returns well. Thus, we want to introduce the true financial meaning here. We can also adjust the portfolio size to test the sensitivity of strategies, and we can find that the portfolio size is larger, the return is lower. In your last section, we implement 3 different optimization models. To illustrate and compare these models, we will only use the M1PESS definition and the predicted returns from the previously tested 2-stage strategy. However, please pay attention that this code may not run well, as you can find the model class. You can tell the result from the code as reference only. Now we have completed today's lab here. We hope you always keep healthy during this unusual period. Thank you.